This is chapter 2 of class 10 polynomials. So we have already learned in our previous classes the polynomials of 1 degree and also what degree means when we have one variable. So 1 degree means linear. So we have discussed about the degree. What is the degree if you have a polynomial and you have variable? The highest power of this variable is known as the degree. So we'll discuss about the degree, which is the linear polynomial. So for example, this one is linear. These one all are linear because we have x to the power 1, y to the power 1 like this. And the polynomial like this, these are not linear polynomial. Why? Because they have x to the power 2, x to the power 3. So what we discuss here is that 2y square minus 3y plus 4. This is polynomial of degree 2. This is polynomial of degree 3. This is polynomial of degree 6. And these expressions, they are not polynomial. They are not considered to be a polynomial. So polynomial with degree 1 is linear. A polynomial with degree 2 is called the quadratic polynomial. Quadratic term or this word has come from the word quadrat, which is meaning square. This is square. So this square, y square or x square, all these you see the maximum power is square. These all are quadratic polynomials. These are quadratic polynomials. So if you have an equation of form ax square plus bx plus c, where this a, b, c are real numbers, then this is called the polynomial. But if we have a polynomial with degree 3, then we call it as a cubic polynomial. We call it as a cubic polynomial because the highest power is 3. Highest power is 3. So this ax cube plus bx square plus cx plus d, this is the cubic polynomial. Why it is cubic polynomial? Because highest power is 3 and you should know that a should not be 0 or a cannot be 0. Otherwise this will not be a, because x cube power will vanish and this will not remain as a cubic but it will become a quadratic. Now, if I place some value at x, let us place x equal to 2 here, means x equal to 2. We say px is our polynomial, we place 2 here. We place x equal to 2 at each and every place. So p2 becomes minus 6. Now minus 6 has come. How about p0? If we place 0 here, x equal to 0, it will be minus 4. But there is one more thing. At some point, if this equation becomes 0, let us take an example. If we place x equal to minus 1, if we put x equal to minus 1, this p minus 1 will make this equation 0. Again, if we place x equal to 4, this equation will again become 0. So at this k or at certain values where this equation, quadratic equation for example, is becoming 0, we call them as zeros of the quadratic polynomial. In later classes you will also know this by the name of roots. Right now we call it as zeros of the quadratic polynomial. So a real number k is said to be 0 of a polynomial if it makes this equation as 0. And as we have seen in the earlier class how to easily solve this linear polynomial, if px is equal to 2x plus 3, then we just put 2x plus 3 equal to 0. So 2k plus 3 equal to 0 means k is equal to minus 3 by 2. Right? Ax plus b, just place k and we say that k, just put a k plus b equal to 0, it will be minus b by a. So this is nothing but minus b by a only. So the 0 of the linear polynomial ax plus b is nothing but minus b by e, that is the negative sign of the constant term, which is the 3 here, which is the b here, divided by the coefficient of x, which is the 2 here, which is the a here. So either it is minus 3 by 2 and if you want to generalize it, it will be minus b by a. So the 0 of linear polynomial is here related to the coefficients. Now, is it true for quadratic? Is it true for your Third one, that is cubic also. Is it true? Let us try and also answer this query. What is the geometrical meaning of zeros of a polynomial? If you have a linear equation like this, ax plus b, just make it some value y is equal to ax plus b, and we know this is a straight line. And this straight line, these are your axes. This straight line will be like this. This straight line can be like this, or it can be like this. Any way it can be. It is going to intersect at x-axis. See, all these are intersecting at x-axis. This can be like this also, parallel also. It will not at all touch or intersect the x-axis. But the zeros of any equation of this sort is that point where this line intersect the x-axis. So this is the x coordinate actually. For example, if we take this y is equal to 2x plus 3, and we see that this line passes through these two. We place x equal to minus 2, we get y equal to minus 1. We just place minus 2 here, we get y equal to minus 1. We place 2 here, and we get y equal to 7. Let us make a line, because we have now got the 2 points. Just straighten the line, and we see here that when we straighten the line, it intersects the x-axis at minus 3 by 2 comma 0. This is the point here, minus 3 by 2 comma 0. Minus 3 by 2 comma 0. So the x, this point x, this where the y-axis is 0, means y coordinate is 0. This is the point we are interested in, and this is what we call as the zeros. So the ax plus b, y is equal to ax plus b, exactly it intersect at one point, that is minus b by a and 0. Now you know the 0, this is the 0. Now let us go for the quadratic polynomial. Just consider this quadratic polynomial x square minus 3x minus 9 minus 4. Again we'll do the same thing. We'll put some values for x, which is origin and somewhere near origin. We take y, we place minus 2 here, minus 1 here, and corresponding value of y we need to find out. So there will be a curve, and this is the curve. We generally know it by the name parabola, and this can be of this form. If ax square plus bx plus c, a is greater than 0, then this is of this form. If a is less than 0, it is of this form, right? So as we see here, this particular curve intersect at these 2 points with the x-axis. So these are 2 zeros here, minus 1 and 4. So minus 1 and 4 are the zeros or roots of this equation, which is represented by x square minus 3x minus 4. So we have 2 zeros. So at most there can be 2 zeros for ax square plus bx plus c. There can be various cases, as you will see, that this graph which we have just seen, it cuts or intersects at 2 distinct points. This is a curve intersecting at this point and this point. Again, this curve intersecting at these 2 points. This is the case 1. Now case 2, this curve is not intersecting, but it is intersecting or touching at one point. So here we have 2 roots or 2 zeros. Here we have just 1 zeros. In this case, it is not at all touching the x-axis or intersecting. So this equation has no zeros, or it has no point where the y coordinate becomes 0. So this equation has no 0. Now we conclude that the quadratic equation can have at most 2 zeros. So what do you expect for the cubic polynomial? Let us take an example. X cube minus 4x will do the same thing. We'll place some values at x and we'll try to find out the value of y. So you see here, y is equal to x cube minus 4x. When we draw it, we see that this point and this point means these are zeros. So you get minus 2, you get 0, and you get 2 here. Minus 2, this and 2. So now these three are points These three are points. We call it as 0. So these are 3 roots or 3 zeros. Here we have just 1 0. Here we have 1 and 2 zeros. Now we conclude for the cubic there can be at most 3 zeros. At most means there can be no zeros, there can be 2 zeros, there can be 3 zeros. And in general, if you have a polynomial of degree n, highest degree n, the maximum possible roots or zeros can be n. Now let us look at this graph or these graphs and try to find out the number of zeros. So here it intersected 1 point, so here we have 1 0, 2 point, 2 zeros, 1, 1, 2, 2 and 3, 3 points, 3 zeros, 1 point, 1 zeros, 1.10, 1, 2, 3, 4, 4 zeros. So this is the first part of our polynomial. We'll be taking the next one shortly. Till then, thank you so much. Take care of yourself.